Old friend again.
The Talon whips you around outside the track at 85 feet per second. Show me the way.
All right, here we go.
Mr. Lubeck's room, you know that ride well.
When I used to work here, I would come in extra early when I worked Talon, just so I could get all my work done in the morning, so I would have a few minutes to ride it a couple times before the park opened.
That's what I'm getting ready to get launched into space here.
Talon is an inverted roller coaster. Track is actually above you. There is nothing below your feet. Here we go.
With nothing under us as we shoot down, we're so close to the ground it feels like we could lose our feet. And in the blink of an eye, we're at the top of a giant loop. The Talon is the tallest and longest inverted coaster in the Northeast. And with your feet dangling at top speed, it literally feels like you're flying.
Go through 4 inversions, and then you finish up with a corkscrew and a helix finale that pins you to your seat for over 5 straight seconds. It's unbelievable.
That was so smooth. I was expecting to be a lot more rough than that. That was awesome. The speed was unbelievable. Like you just fly into it, and it feels like you're literally flying because you're dangling.
You got nothing below you. It's awesome. You're just flipping all through the air. You're in your seat, then you're out of your seat, then you're upside down, then you're going side to side. But it's smooth too, so you're all over the place, but it's enjoyable.
Without a doubt, I get why this is your favorite ride.
Absolutely.
Yeah, aside from the nostalgia you have for it, this was probably one of the best ones I've been on that I would like to continue going on.
Definitely.
Yeah, so you're going to take me on that again, right?
Definitely. Oh yeah, we'll definitely go on it again. I got the soft spot for it, but it's a good ride on top of it too.
So that was a lot of fun. So that was about, that aired, oh geez, 4 or 5 years and 25 pounds ago for me. So I might have been able to tell there. So that was a lot of fun. Roller coasters is actually what, the reason I put that in there is that's how I first got interested in engineering. The dream job is to design roller coasters, right? So maybe one day, blue sky aspirations, right? So lastly, I'll talk a little bit about my co-op experiences, just to give you some examples of places that have good relationships with RIT. So I did some work at Fisher-Price. Yes, that Fisher-Price. And these were 2 of the guys that I worked on. The Batmobile Imagine-X. I designed the disc launcher, which comes out of the front. The motor shakes back and forth when the car moves, and then the engine in the back. The flame inside of it spins. So those were mechanisms that I designed in Creo Pro-E, almost exactly the same as Inventor. I use Inventor on my personal computer. We use Creo at Raymond. That's what they used at Fisher-Price. A lot of those CAD packages are pretty interchangeable. All things are pretty similar. So if you can do Inventor, you can do Pro-E, you can do SolidWorks, you can do NX, any of those programs. So it's really good to know that side of it. Also worked on a similar mechanism with this dinosaur guy. I had both of these at my house. When I heard that they were launched, I actually went out to Targets and Walmart looking for them. It took me forever to find the Batmobile, but I got a couple of dinosaurs. And of course, I immediately needed to take one of them apart to see if it was still the way I designed it. And they were, so that was good. I also spent some time at the MOG, Space and Defense group, which people don't necessarily know MOG. MOG does a lot of actuators and servo valves for Boeing, Lockheed Martin. They do a lot of those in the aircraft group. I was in the Space and Defense group, which does a lot of work for commercial space programs. So if you know SpaceX, they do work with SpaceX, and also Orbital Sciences, who did the Antares project, which is a resupply mission, an unmanned resupply mission to the International Space Station. So they send several rockets up to the space station periodically as part of the Antares project. So that's where a lot of my work there. So, questions about me before I move on? Good? All right, cool. So, who here has heard of Raymond, the Raymond Corporation? Anybody? Who thinks they might have heard of Raymond once before? I'm interested in where you might have seen it. What?
On the side,
Probably. We have a dealership in Briningsville, so you may have seen one of our dealer trucks going around. Has anyone heard of Raymond? No? Okay. Good. So, who's heard of Toyota? Heard of Toyota, right? Everyone's hand goes up in the air, right? So Toyota, everybody knows Toyota cars, right? The Corolla, Camry, that is Toyota Motor. Toyota as a whole, what we call TICO, is Toyota Industries. Toyota Motor is just a small group. There's also Toyota electronic components, Toyota textiles, a lot of different materials, textile materials, Toyota logistics, shipping, receiving, all that sort of good stuff. And then Toyota material handling, which includes Toyota, which is TMHA, Toyota Material Handling Asia, BT, which is in Sweden, so that's Toyota Material Handling Europe, and then TMHNA, which is Toyota Material Handling North America. Under the TMHNA umbrella is the red trucks, as we call them, which are the Raymond trucks. So we do forklifts, pallet trucks, that sort of stuff, and we are owned by Toyota, okay? So we're under the Toyota umbrella. We were acquired by Toyota in 2002, 2003. So we've been under the Toyota umbrella for about 15 years. I've been there about 3 years. They've kind of let us do our own thing, but they've implemented a lot of efficiency, higher quality standards. We follow a lot of Toyota practices that have made our product better. Before we were under the Toyota umbrella, we used to average about 2 defects per truck out of our factory. We've lowered that in the last 15 years to about 0.2 defects per truck. So 1 defect in every 5 trucks that leaves the factory. So Toyota's been a big part of that, and that's part of the reason we've grown so much. So, you heard of any of these guys, right? So everybody knows these. These are our big customers. So all these places buy trucks from us for their warehouses. The big one right now is that one in the middle, Amazon, right? They're growing so much. You've ordered stuff from Amazon all the time, right? So anytime you get a product from one of these places, more than likely it's been touched by at least 2 Raymond trucks, probably 3 or 4 on its way to you. So to give you a little bit of background, Raymond's been around for 96 years. Our largest customer has always been Cisco. You've probably seen Cisco trucks from time to time. They're more of a logistics corporate. So an example, the Cisco in Portland, Maine, ships out food products to all the Stop and Shops in New England, Shaw's, Star Markets, all those supermarkets up in the New England area. Cisco ships out all their product to all those different locations. They've been our largest customer as long as most people who work there can remember. Amazon ordered their first truck from Raymond 4 years ago, and by this time next year, they will have ordered more trucks from Raymond than any customer in our history. That's how many trucks they've ordered from us in just the last 5 years. So that gives you a good idea of how much Amazon is growing, and we're a big part of that. So that's why, this is why what we do is important. We're constantly growing, constantly hiring, constantly coming up with new stuff to meet their demands. So I'm not going to go through all this, but these are just some reasons I like working at Raymond. We do a lot of community outreach. We donate a lot of trucks. We donated 11 trucks last year to hurricane relief down in Florida to the American Red Cross. I think it was Maria. Hurricane Maria was the big one last year. So we've done that. We've donated trucks to RIT, Binghamton U, SUNY Broome for their purposes. We've also donated hand trucks to our local high school and middle schools to help their janitorial staff and whatnot, move stuff around. And then just in the last year, we won a bunch of different awards. Probably the most notable is our CEO, Mike Field, who is an engineer. He's an engineer by trade. He went to RIT, and he is now our CEO. He's been our CEO for about 7 or 8 years. He was recently named the RIT Distinguished Male Alum for 2018, which is pretty cool. And our VR training simulator, which I have a video for on the next slide, recently won an innovation award at our industry trade show last year. So we're doing a lot of new things, a lot of cool things, a lot of different things, some of which are up there. So now I've got a few videos here, and so the ones that are underlined are videos, and I can show you 2 or 3. We have time for 2 or 3 of them. I want to show you the VR simulator, so I'll show you that first, and then you guys can kind of pick which of the other ones you want to see. So the background for this, as I pull it up here, I'll talk while I'm bringing it up, is Amazon wanted a way to train their operators before they actually get on a truck and before they actually drive a truck. The problem with that is it's very, very hard to do simulated training on a big forklift that weighs 8,000 pounds, right? So a standard reach truck that we do weighs about 2 times as much as Mr. Lubeck's pickup truck. So his might weigh 3,000 or 4,000 pounds. Our trucks weigh about 8,000 pounds. And most of them can take 4,000 pounds or more up to 50 feet in height. Some of the bigger trucks maybe 60 feet, but generally that's what you're looking at. So it's very hard to do training on that type of thing without actually being on one. So what we came up with, and this is new within the last year, you put on like basically the Samsung VR goggles, and it comes in a big case. If you're in digital electronics, you know, the big case that your breadboard comes, or at least it came in when I did it. It's about this high off the ground, and it's got a computer in it and a screen, and it hooks into the truck, and it disables the truck motion. Then you put on the VR goggles, and the operator gets in the truck and actually drives the truck with the real controls on the real truck, but it disables all the movement, and it hooks up to the computer into the virtual reality world, and that's how they do their training. So this video here is actually the VR world. And it's a 360 video.
Look around you. In the warehouse and
On your
beyond,
mobile phone, you can actually
Raymond
look
is
around.
there, always thinking about your business, always moving you forward. And to keep you ahead of the curve, Raymond is the only lift truck manufacturer to provide virtual reality learning on the real trucks on your warehouse floor. Our platform is designed to help you unlock 360 degrees of potential through a virtual reality learning system that is simple to use, easy to connect, and works with your existing family of Raymond forklift trucks. Your operators will get ahead with hands-on learning on the trucks already in your fleet in a risk-free, physically accurate, plug-and-play environment with a variety of instructional modules available for your reach, order picker, stand-up counterbalanced, and other Raymond trucks. You can choose the right course for your business and your team. Start with the basics. In your reach truck, travel down aisles, approach an intersection, navigate traffic, and put away a pallet. Or select a lesson for your order picker. Your driver can elevate to a height, pick items, and then proceed down a wide or very narrow aisle. Advanced lesson modules include activities like driving a stand-up counterbalanced truck and loading and unloading a tractor trailer. From driving and elevating and racking to retrieving and...
So that's what our Raymond virtual reality training world looks like, right? And that's something that's being worked on by electrical engineers, obviously software engineers, but also mechanical engineers, because they need to properly duplicate the trucks in the virtual reality world. So the trucks that are moving around in the VR world are Creo models that our engineers have built and translated into the virtual reality world. And again, it's not coming up as a 360 video. If you have done the 360 videos on your phone before, you'd be able to pan around, but because we're on the computer, it's not a 360 video. So that's one of the cool things we're working on. What of the other three interests you guys? People like the automation stuff. This one? So, let's see this one come up. Yes. Okay. So the background with this is, so we'll get into it when I talk more about my engineering experiences. I'm going to refer to a truck that we call the second level order picker. So an order picker truck is exactly what it sounds like. You pick an order for a customer. So on a pallet truck like this, in this video, he has an end rider truck that is a double fork length. So they're 96-inch forks, they fit 2 pallets. First pallet might be going to Walmart, the second pallet might be going to Kmart, if they were still in business, right? So what he has to do is he goes through the warehouse, and when he gets to a pallet location of something that Walmart or Kmart has ordered, he stops, and say it's a case of water, he gets off the truck, he picks up a case of water, and he puts it on the correct pallet. So what's the problem with that? What if you put the wrong thing on the wrong pallet, and you don't give the customer what they ordered? So there's always been a big deal about mispicks and sending the customer what they didn't order. So the pick-to-pallet system is an LED light system embedded in the sides of the forks that when they have a scanner on their wrist, they scan the product that they're going to put on the pallet, and the light underneath the pallet that it needs to go on lights up so they know which pallet it needs to go on. So that's what this talks about.
Picking costs representing up to 55% of total warehousing costs, customers are demanding better order picking product solutions. Solutions that not only boost productivity, but also minimize batch picking errors, where mixing product on customer orders can be costly. Raymond's pick-to-pallet option utilizes proven put-to-light technology within the pallet truck forks. These lights act as a beacon, directing selectors to the proper pallet to place product, removing guesswork and minimizing pick errors caused by placing product on the wrong customer pallet. Customers using pick-to-pallet report up to a 20% productivity increase and up to a 35% pick error reduction rate versus pallet trucks without pick lights. Here's how it works. Pick-to-pallet integrates the truck with your existing warehouse management software and voice pick equipment. The warehouse management software sends pick directions to the selector through the voice pick headset, telling them where to go, what product to pick, how many pieces to pick, and on which pallet to place the product. When the selector confirms the pick location by saying check digit, the truck lights turn on under the target pallet position. When the selector confirms the quantity picked and the customer by saying, for example, 2 alpha, and places the product on the pallet, the truck lights turn off. Simple, effective, productive, and durable. Long-lasting LED lights are securely protected by the fork frame with lenses. 2 bolts provide easy access to IP65 water-protected electronics, ensuring long-term, reliable performance. Raymond's new pick-to-pallet LED light system, the ideal solution for reducing picking errors and increasing productivity. Contact your local Raymond Sales and Service Center for more information on how this innovative order.
So that's kind of cool, right? So as they said in the video, they increase productivity and efficiency by up to 20% and reduce pick errors by 35%. So why is that important? Number one, the customer is getting what they asked for more often, and they're getting it faster. It's also important to the operator because in most cases, those operators get paid by the pallet. So every pallet that they pick correctly and send out, they get paid for each of those. So 20% efficiency increase, they're getting paid more. So automation is probably one of our biggest drives right now. I'm currently working in the automation department. And again, that's being driven mostly by Amazon. The deal with automation is if you're in a warehouse where you need to move something from one place to another to the other side of the warehouse, you could have an operator driving that forklift back and forth all day long. But if it's going the same route all the time, why not have the truck do it by itself is the mentality we came up with. So about 4 years ago, we came out with our Courier product line, which is an automated pallet truck for what we call horizontal transport, repetitive horizontal transport, and this is what it looks
For
like.
warehouse operation on pace with the economy of now, you need the next generation of automation, and Raymond is leading the charge. The Raymond Courier automated lift trucks provide flexibility, scalability, productivity, and performance. Built to work seamlessly alongside your existing fleet and designed for faster initial setup, multiplying your workforce with no additional labor costs and no changes or additions to your existing infrastructure. With vision-guided technology and built-in sensors, Courier trucks don't just know the routes, they see them. Routes can be easily programmed, reprogrammed, stored, and transferred between trucks. And if it detects obstruction, it stops until cleared. A powerful supervisor software allows you to see the big picture, The supervisor sends reports
So if you
directly
don't
to
like
you or
engineering, you
your
can do the
operators,
math.
enabling you
Part
to
of
control
warehouse
multiple
management
trucks with
system
greater
too, is
efficiency.
stats.
That's real-time fleet management. The Raymond Courier features multi-purpose modes, so your team can easily switch to manual operation when the situation demands it. The Courier can also be redeployed as needed, so those small orders, or the unexpected ones, can be handled without skipping a beat. Evolved from the rugged, proven design of the Raymond pallet truck and tow tractor, the Raymond Courier handles the repetitive, horizontal tasks, so your operators can focus on activities that are more productive. As simple as the Courier is to program and operate, it's just as easy to maintain. And with the added assurance of Raymond's unparalleled direct service and support, with an extended network of more than 100 plus service locations throughout North America. From implementation and everyday efficiency to on-time delivery and lower total cost of ownership, nothing beats Raymond Courier. To keep competing in the economy of now, find out what the next generation...
So you can see how something like that would be pretty useful for an Amazon if they need to take a pallet from one end to another. They can have their operators spend time doing the order picking, the things that a human has to do, and transferring things from one to another can be done automatically. So that's a big thing that Amazon is interested in, trying to reduce, increase productivity and reduce how many operators they're having actually drive trucks around. So questions on Raymond before I get to what I know Mr. Yoke and Mr. Lubeck and Mr. Kessler are going to really like with the design process. Yep.
How did you get introduced to the company?
How did I get introduced to the company? So actually through RIT. Twice a year, RIT has career fairs where several different companies, SpaceX, Toyota, IBM, Moog, for example. Let's see, Hewlett Packard's always there. A lot of big name companies, right? Raymond comes to the career fair every year, and I went to my advisor prior to the last career fair before I graduated and said, you know, what are some good companies that, I said, you know what I like, you know what my interests are. Give me 10, 12, 15 companies I should go talk to. Raymond was one of them. I had 4 or 5 interviews after that career fair. Raymond was one of them. I interviewed, they invited me for a second interview on site. Went, took a tour of the factory, interviewed with a bunch of different engineers, and they said I would be doing mostly CAD work, which is my wheelhouse. I always enjoyed the CAD work the most. I'd be getting into the lab, actually getting my hands dirty, working on trucks from time to time, and that interested me, and that was the best fit for me, and so far I didn't make the wrong choice so far 3 years into it. So that's how I got introduced to Raymond itself. I also had a hockey teammate of mine who was actually doing a co-op at Raymond at the time that I got hired, so I was able to say, hey, you know, what kind of work are you doing? Do you like it? Do you don't? And he really liked it, so I got a vote of confidence from him as well.
What exactly do you do there?
So in new product development, we'll design ground up trucks. We'll design the whole truck, and then we'll design new options for the truck. So right now we're working on like 7 or 8 different things in automation. We're working on a modified version of the courier truck that you just saw to better fit Amazon's needs. They need something a little bit different. I can't exactly say what it is yet because it's not out for sale yet. But they need a slightly differently performing truck. They need to do something a little different with them, but they want to automate that process. So we're working on that. And then we're also working on automating some of our other trucks that currently are operator only. There's no automation involved with them yet. So we're working on automating some of those as well. Yep.
I don't know if you mentioned this, I may have missed it, but the part of the engineering design division that you're working with, are there other locations in the country with Raymond, or is it just New York where you're at?
Yeah, so most of the engineers are in Green, New York. We have a small, so our big trucks, the swing reach trucks, the reach trucks, the order pickers are built in Green, right there at our factory. The pallet trucks like this, the second level order picker, the picked pallet truck, the 8410 model, those are built in Muscatine, Iowa, which is right on the Mississippi River on the Illinois-Iowa border. So I go out there usually once or twice a year. Our parts division is in Syracuse, New York, so there's not so much engineering opportunities there. That's where the customers order spare parts if they need to replace a part, or if they want an aftermarket option that we work on. So that's the other thing we'll do. We'll come up with new options that can be added to trucks, which is something I'm also working on now. They would order those from the Syracuse Parts Division. We acquired a company that's in Columbus, Indiana, that builds a couple different trucks for us. So most of the engineers, I would say about 85% of the engineers are in green. Muscatine has a few. The company in Indiana has a few. Most of them are in green. All right, so I'm gonna move on to this guy here. So who's seen this picture before or something very similar to that picture before, right? Everyone's hand should be in the air, right? Yeah, Mr. Yoakum. So this is the design process, right? What does Mr. Yoakum always say? It's all about the process, right? I remember my very last day of EDD. That was an extra credit question on the very last day of school. What's that? Yeah, but it's true, right? So I'm gonna have some examples of how to follow the design process and why it's important. So it's an engineering design process, but it's also an overall project design process, because just at Raymond, these are all the different types of engineers you have. You have mechanical, electrical, software, quality, test, manufacturing, all these great disciplines that you could get into, right? But then you also gotta deal with all these people when it comes to a project, right? You got to deal with drafters. They're making your engineering drawings, which is something that you're having experience with through PL2W. Project management, they're actually running the project. They're coming up with your schedules. You have to design your product so that manufacturing and assembly can actually put it together, right? You need people to buy your parts. That's procurement and purchasing. Sales and marketing. We have people going out all the time to customers, finding out what they want and what we can do better. Sales and marketing people figuring out what we can do better to sell more trucks. It's a constant battle between our competitors, Crown, Yale. Toyota is actually a competitor of ours because Toyota does their own trucks. So we're competing with the company that owns us sometimes for customers. Pepsi is a good example of that. Pepsi orders some trucks directly from Toyota and some trucks from us that we paint orange and put Toyota stickers on instead of Raymond red stickers. It's a really weird process, right? So you wouldn't think that you'd be in competition with the company that owns you, but sometimes you are. So it's a constant battle trying to get better, and working with all these people is important. That's why communication is important, because these are all the people you have to talk with all the time, technical and non-technical, right? So I'm going to breeze through this 12-step process, how it might work for a typical Raymond project. So marketing will come at us and say, hey, Amazon wants this. They want a forklift that is a hover car and it, flies up 50 feet in the air, and they want to pull 8,000 pounds out of a rack location 50 feet in the air. So they create an MRD, a marketing requirement document that says, here's what the customer wants, here's the customer requirements. So we go through some brainstorming, generating of ideas, and we get down to where we identify criteria and constraints, and we create and engineer functional specification. That's the engineering response to the MRD. So marketing says they want an 8,000 pound capacity hover car. We say, well, we can't do that in 6 months. So here's what we can do. That's what we do in the functional spec, right? So this is important here. That's not solving the problem. That's determining the requirements to solve the problem. So if we need to take 4,000 pounds 40 feet in the air in 15 seconds or less, that's a requirement. We can test that. We can see if we pass that test, okay? We can do that in a lab. We're not coming up with the idea just yet of how we're gonna do that, but that's what we need to accomplish. Those are things that we can check the box at the end of the design process and say, yeah, we do that, yeah, we do that, yeah, we do that. That's where we do that, in that stage. Then you start doing your exploring possibilities, as it's called, where you come up with different concepts. Now, at Raymond, remember this next step here. Select an approach where we hold cross-functional design reviews. We'll get 15 engineers in one room, and we'll say, here are 5 concepts of how we think we can meet this requirement. We think concept 2 is the best. So the goal of a design review is you get all the engineers in the room to say, yeah, we agree. Concept 2 looks like the best option. Let's move forward with that. Or you might have 5 engineers say, well, what about concept 4? That looks better. And 3 engineers might say, well, concept 3 looks good to me. So you probably got a little bit more work to do because you haven't convinced your audience and all the other engineers in the room that that's the best idea. So it's good to have those design reviews because you get multiple sets of eyes on things as opposed to 1 engineer or 2 engineers who have been looking at the same problem for 6 months and have kind of pin themselves into one way to solve the problem, right? So that's an important part of the design process. That'll come back in a later slide. So then once we move forward, we start doing our models, our drawings, things like that, and then we build them. We mock them up in our engineering lab. We'll do some testing. We'll do some destructive testing. Last week, that new automated truck that we're working on right now, we actually put it on our tilt table and tilted over till it fell over, because there's a stability requirement we have to meet in our safety standard. So we test to that standard and make sure that the truck can tilt a certain angle and doesn't fall over. So we do fun stuff like that in the lab every once in a while. Then once we come up with an idea, a design that we're happy with, we'll send it out to what we call field trial. And that is a customer that has signed a non-disclosure agreement. They say, yeah, we'll test this new product out before you launch it for sales. We'll give you feedback. We'll tell you our problems. We'll tell you what's breaking. We'll tell you what we like. We'll tell you what we don't like. And we create a technical problems list. And we decide, okay, we need to do something about this. We need to do something about this. We can live with that one. You know, if they don't like where the grip of the control handle is, but it's only 1 or 2 operators and not 8 or 10, we can live with that. So we'll decide what's important enough to fix, what we can live with, and what is just maybe them being complainers and being a nuisance, right? You don't want to tell the customer you can do everything they want, right? Because then you don't have control of the design. The customer thinks they want something, but what they might actually want is something else. So you don't always want to give them exactly what they want, because they may not know what they want, or they may not know what's going to solve their problem best, okay? So then finally, we make all these changes. We go to the create or make. We do our final documentation. Technical publications will write work instructions. Manufacturing and assembly will actually build some trucks on the production line, and they'll get an idea of just the process of a truck going down the assembly line. And then finally, when all that is done, we launch the product. We have a press release, say, hey, this new product or this new option is out there for sale. That's all marketing and sales. They'll do that side of it. But they need to communicate with engineering to properly say what the truck does, right? They need to say what the customer is going to use it for, and hopefully it solves all their problems that we got back in step 1. Questions? So that's kind of how the design process that you're seeing in PLTW feeds into a real world engineering project. Good? Questions before I give you some good engineering examples, things I've dealt with? All right.
Oh, one in the back here.
Oh, yep.
During the creation process, do you physically do that yourself?
Say that again?
When you're creating, do you physically do it yourself?
So during that stage, we'll do the CAD models. And what we will do is we will go through a process we have to have those parts made in our factory. So the engineers themselves won't go through and create and make everything, but our manufacturing personnel will. So if we need a sheet metal part bent a certain way, they'll do it on the machines we have in the factory. So yes and no, we'll design it and we'll have them make it, but the people who make all our parts will make it. Or if we can't make it, our purchasing people will find a supplier who can make it for us. So electrical components, we don't make electrical components, we buy them from somewhere to put into our trucks. So if we need a sensor for one of our automated trucks, we don't make the sensor. We come up with what the requirements are, and here's what the sensor has to do, and then we give those to our purchasing department, and they'll go find a sensor that meets those requirements, and they'll identify the supplier, and then our logistics people will order it from them. So right there, you've got like 4 different groups working together just for a prototype, right? Does that answer your question? Good. Anything else? All right. So I've got 4 of these, what I'm calling technical experiences. I've got 2 mechanical, 1 that's a little bit of mechanical and manufacturing, and the second one is electrical. My favorite one is the last one, which is why I saved it for last. So the first one here, this is going to deal with mechanical design, meeting safety standards, and stress and deflection analysis. So the scenario here is we're designing a new truck, and it's got this big steel plate on the back end of it as part of the operator compartment. So I talked about the industry safety standard that we have to meet. That is the B56.1 document. There's several different sections. We have to comply with all of those sections before we release a new truck. So in a lot of cases, like this one, it'll tell us that if we have a part like this that's supposed to keep intrusions from going into the operator area, we need to pass this impact test. So fully loaded truck, 1.6 kilometers per hour, and we can't have deflection of greater than 100 millimeters. So we have to do that impact test, right? We have to take the truck out into the lab, go at that speed, and run it into a rack beam that's 75 millimeters high, and then measure the deflection. And we have to make sure we meet that standard, right? Because you can imagine if the operator's standing here, he's got this wall behind him, and he backs into a rack wall, and that thing goes 200 millimeters this way, he'll get crushed between the battery and the wall in the back. That's how you get sued when you injure people, right? So that's why this standard is in place, so that you're not injuring operators. You have to have a strong enough part. So when you have a failure in engineering, we always ask ourselves the 5 whys. You ask yourself why 5 times to get to what we call root cause. So this part failed. Why? Well, it wasn't strong enough. Why? Well, we got defective material. Why? Well, they didn't do their inspection. We didn't do our inspection of the material when we got it in. Why? Well, the inspection guy wasn't properly trained on how to inspect the material. Why? Well, our training material isn't good. Okay, so we gotta fix our training material, right? So you get to the root cause of what actually went wrong instead of putting Band-Aids on. The other way, when you're trying to make a good design, you ask yourself how. So how do we meet this standard and make a good design? Well, make a good truck. Well, we have to pass that test. Well, how? We make a strong design that's capable of passing that test. How? We analyze our forces that come from here, right? How do we do that? Well, we have to do our impact force calculations and maybe a free body diagram. Free body diagrams sometimes help with things like this. This is a pretty simple one. So along this bottom surface here, that plate is welded to the tractor. So a weld is a fixed constraint, right? It's not moving in any direction. It's welded in place. And the standard says we have to have this force up at the top here, because that's our worst case. That's our biggest moment arm, right? So that's going to provide our most deflection if we apply the force up there at 75 millimeters. So we do our impact force calculation based on the weight of the truck, fully rated load, and the speed of impact that they define for us here. And we do this calculation, we figure out our impact force is about 1,500 pounds, and we're going to distribute that across 55 millimeters. Now, if you're in physics class or maybe a POE class, you'd probably go and do that calculation by hand, right? Well, we can do what we call finite element analysis in Creo. Creo has it's a tool called Simulate, where you can apply forces to a part. You set material properties for that material, so we set it as whatever our grade steel is that we're going to use for this part, and we run the analysis. And we can check out our stresses, see if we're over yield strength, see if we're over ultimate strength, see if the part's actually going to break. But in this case, we're interested more in the deflection. So based on the material properties, it'll tell us how much this part is going to move on that impact. And we want to make sure that it's under 100 millimeters. So we apply our fixed constraint at the bottom, do our force there, and we run the analysis. And that dark red portion is the most deflection, and we got millimeters there. 27 millimeters. So this is a really good design, right? We've got a safety factor of almost 4 because we need to be under 100 millimeters and we're at 27 under that loading scenario. So we can make this part, test it in the lab, and have a high level of confidence that we're going to pass that test and meet that standard. Now, if that number was 95 millimeters, do you think we'd be building it and testing it? Probably not, right? We want a higher safety factor. Usually we do a safety factor of 3 or more. That's usually our rule of thumb. There's actually a part in the B56.1 standard that says if it's a load-bearing component with the normal operation of the truck, which this is not, you have to have a safety factor of at least 3. So those are other tests we have to do. So the end game here is we built this, we did the test, passed with flying colors. Good design, right? Follow the design process. Good design. Questions on this one? This one's pretty straightforward, and this is something we do all the time. This is a regular occurrence in the engineering world. Good? Okay. I'm gonna go through this one quickly. This is an electrical one. How many people here are interested in electrical? Okay, a couple, so we'll go ahead and do this one. So this is the 8720 second level order picker. So this is similar to the pick to pallet, the LED light video. This is similar to that, except the operator compartment goes up 4 feet, so they can pick product from the floor level, but also the second level rack, so they can get up 4 feet in the air. And it has an operator sensing floor mat. It tells the truck when the operator's on the truck, and it disables truck travel when they're not on it. So they can't stand to the side, drive it, and run over their own foot or run it into something else. It basically disables the truck from moving when they're not on the truck. That's the idea. The problem is that floor mat is not safety rated by UL, which is Underwriters Laboratories. They write the electrical standard. And if you open up your refrigerator at home, you'll see a sticker on the inside that's got UL inside of a circle. That means that that refrigerator is safety rated against shock, fire, electrocution. Hand dryers, a lot of hand dryers in the bathroom will have those. Christmas lights have a big UL sticker at the end by the plug. So that basically means if it gets fed too much current, it's not going to catch on fire, it's not going to shock you, it's safety rated for those purposes. This floor mat was not safety rated. So to meet the standard, we need to limit the current somehow going to that floor mat. So how can we limit current to the floor mat without changing anything else? Ideas? Increase the resistance, okay. Other ideas? So we could do that, but according to UL, that's not good enough. Because they can still, it's coming from an unregulated power source, so we could still overload the floor mat. It would be harder to do it, but we could still do it. We want to make sure there's no way we could possibly do it. So what happens when you turn on all the lights and appliances in your house at the same time? What happens? It shuts off, right? And what causes that to shut off? Right, the breaker box, right? So in the breaker box is a bunch of fuses. Okay, so when you put too much current through that circuit, it trips the breaker because the fuse is only rated for a certain amount of amps, certain amount of current. So what we had to do was put an inline fuse between the power source and the floor mat. Now, again, I'm a mechanical engineer, but this was my problem to solve because I was doing electrical work at the time. So only having a little bit of electrical experience, I had to go through and solve this problem. So these are all the things we need to do, and to stay on schedule, we couldn't alter anything else on the truck. So here are the two connectors where the floor mat plugs in, and we need to limit it to 2 amps of current or less in order to meet the safety standard. So we need to find a 2 amp fuse that is UL approved, okay? So that meets the safety standard. We need a fuse holder that's UL approved, so that if the fuse blows, the fuse holder doesn't catch on fire or electrocute, because it's on the bottom of a metal part, right? So if the fuse holder isn't UL approved, you're going to essentially make the operator compartment a part of the circuit, and you're going to shock the operator. You can't do that. So, and we need to provide instructions on the assembly line, because this truck is already going down the assembly line for prototype builds. We need to give them instructions on how to put this part onto the truck on the assembly line. So we found this little fuse holder, looks like a torpedo, right? And this is in Creo, in CAD. We designed this simple little model, right? Made our engineering drawing. This is one of my drawings. We looked on the supplier data sheet. They make it in a clear and a black, opaque color. Only the black one is a material that's UL approved, so we have to specify we need to use the black one, okay? And we say that we need to put a 2 amp fuse in it, which is part of our bill of materials at the bottom of this assembly. We've got the fuse holder, we've got the terminals, we have the wire, and then inside the fuse holder is the 2 amp fuse. and it's hard to see here, but this note 4 says that the fuse needs to be on that end. That's the floor mat end. This is the battery end. Why would we want the fuse on the floor mat end and not the battery end? So if you go up and touch a copper wire, what's going to happen that has electricity running through it? What's going to happen if you touch the copper? Yeah, you're going to get shocked, and it's also going to be very hot, right? Because as the current's running through it, it gets really, really hot. So if you unscrew that fuse holder, and the fuse is on the side of the battery, and it's connected to the battery, the end of the fuse is going to be really hot. With it being on the floor mat side, you can touch that fuse and pull it out, and you're not going to burn yourself or shock yourself. So that's an important part of this that you might not think about. So then we gave our rework instructions and said, hey, disconnect those 2 terminals, hook this guy in, and then just zip tie it to the other wires that are already there. Truck worked just like it did before, but now we've protected the floor mat circuit to not see more than 2 amps. So now we meet that safety standard. Okay? Really, really simple solution to what could be a real big problem. Only took us a few days to come up with this and get a few made in our electrical assembly area and try it out. Okay? Now, the happy news at the end of this is we went back to the supplier of the power source and asked them to test that pin to see if it was regulated, but that was a six-month process. We didn't want to wait 6 months because we had to launch the product. So once they came back and said, yep, this meets the requirements, all we had to do, take that guy out, throw away the instructions, hook it up like we normally did, and that was the benefit of not touching any other parts. Once we got the word that the power source was regulated, and they confirmed it with their testing, we take this out, we reduce cost of the truck, and we didn't have to redesign anything else because we didn't touch it in the first place. Yep.
How much reduction cost was
The fuse holder is actually fairly expensive. The wires and the terminals aren't too much. The fuse holder itself, I think, is like, it's like a $20, $30 part, which doesn't seem like a lot, but in green, we ship 75 trucks a day out the door. In Muscatine, we ship 125. So when you think about that, this could be used on a lot of those other trucks. On the 8720, because it's a new project, it's only launched about a year ago, we don't have tons of sales, but if we're selling thousands of these a year, all of a sudden $30, $40 a truck is a big deal, right? It's more money in our pocket, and because we're privately owned, we're not on the stock exchange, so at the end of the year, all of our profits go in the employees' pockets as part of profit sharing. So the cost reduction ends up coming back to us because that's more profit, the employees. So that's why maybe a $20 reduction in cost might matter to you. Questions on this? Okay, let's see, how are we doing on time here? Okay.
I don't think we need to rush.
Okay, all right, we're good. Number 3, this is about design for manufacturing, tolerance stack up. I recall hearing that phrase when I was here many times, and assembly. So, on the surface, this looks like a real easy problem. And I've simplified it, but this is a simplified version of a real problem. To go through the real problem I dealt with is probably about an hour discussion by itself. So I've dumbed it down to maybe about a 6-minute conversation. So we've got the steel bar, silver piece with 4 holes, 4 threaded holes, and we've got this red painted bar with 4 through holes, and we want to attach these 2 parts using 4 bolts. So the challenge here is design the red bar so that it will always fit. It will always assemble. Seems like an easy problem, right? Okay, so let's dig into it. This is the drawing with dimensions of the steel plate. Pretty simple, right? It's a 6-inch high bar where your holes are centered vertically, and the holes are located from this edge, 3 inches, and then they're 6 inches apart. They're M6 holes, 6 millimeter holes, so in inches, that's 0.23 inches, roughly. So remember that number, 0.23 inches is the diameter of those holes. Okay? Easy, right? Simple. This is something that you could go, you could go into Inventor, you could make this part, you could make the drawing in Inventor, and you could probably do this in, wouldn't take you long, right? But then you get into the tolerances. So here's the dimensions, but that first hole is never going to be exactly 3 inches from that edge, right? Because your manufacturing, your machines aren't perfect, right? We don't live in a perfect CAD world. In CAD, everything works, right? Because you can make everything exactly what you want it to be. In the real world, that's not how life is, right? Nothing's perfect. So in order for this part to meet our print, we need to give our inspection people a tolerance. So we say that this hole is nominally 3 inches from this edge, but we're going to give you 20 thousandths on either side. And we're going to do the same with all these other holes. So hole number 1, the center of hole number 1 can be located anywhere, and I'm not worried about the Y direction right now. I'm just going to do the X direction. When we do the Y direction, this becomes too long of an example. So we'll just worry about the X direction, okay, side to side. So the center of this hole can run this way and be located somewhere in that range, and it'll meet the print. Same thing with second hole, third hole, fourth hole. Everybody with me so far? Makes sense, right? Okay? So now what about the red bar that we need to attach it to? Well, the engineer decided to dimension this part in this manner. So we have the same thing here, 3 plus or minus 0.02. So the range of acceptable values for hole number 1 of the red part is the same as the gray part. Now, these through holes are 0.27 in diameter. And what did I say was the threaded hole diameter? 0.23. So that's we have 0.04 inches of wiggle room, right? So the centers of the holes on the 2 parts can be as far as 0.04 inches apart from each other, and the bolt will still go through the through hole and thread into the threaded hole and attach the part. So in this first hole, we're good, because the worst case scenario, they're 0.04 apart. Where we start to run into problems is we've dimensioned the second hole off the location of the first hole, and we have the same tolerance. So now this 0.02 tolerance is stacking up through all 4 dimensions, right? Does everyone see that? See how that works? So when we get to the last hole, all of a sudden, we have a range of values that, based on the location of the previous holes, could vary 0.16 inches. That's over 1/8 of an inch. And as you can see here, if this one's at 20.92 and this one's 21.02, that bolt's not going through that hole, and you're not getting these 2 parts bolted together. So what are some ideas on how we can fix that?
Don't use chain dimensioning.
Don't use chain dimensioning, right? So this isn't a good idea, right? It would be a lot nicer if we did that and did exactly what we did on the gray part, right? Because now this hole is not dependent on this hole is not dependent on this hole, so on and so forth. So we've gone from hole number 4 having this wide range to it having the exact same range as the gray part. So again, in the CAD world, that dimensioning scheme and that dimensioning scheme, that's the same exact part. In CAD, in Inventor, that's the same exact part. It looks exactly the same. But that part's not always going to go together. That one will. We actually had a case on the assembly line where they were putting parts together, and they called up the engineer and said, hey, we can't get your parts together. They came out, he did a tolerance stack up, everything looked like it should have been okay. It was a scenario like this, right? He threw the one part back in the bin, pulled out another one, went together fine. And it was at the absolute worst case where this was 20.98 and this was 21.02, and it was just enough that the part wouldn't go together, but then he grabbed a different part where this one was at 21 and it went together fine. So this is something we deal with all the time. All of our assemblies, we have to do tolerance stack-up analysis on to make sure that we can always put it together. So this is real simple, right? This was really a 4-step stack-up, right? In the real world, you're more likely to come up with something like this, which is 17 steps and goes across 4 different parts. So this is a part that I designed for the second level order picker, the man-up truck that goes 4 feet off the ground. there is a storage shelf that is an option that attaches to that operator compartment. So when they go up, they can put boxes on the shelf, come down, then they take the boxes off the shelf and they go put them on the pallets. So this is an option they can have. And what happens is the shelf is a big square sheet metal form part. It's got some welds in it. And then we bolt on some mounting. What things do we need to account for when we're trying to figure out how much load that caster is going to see? What things do we need to think about? Weight of the truck. Weight of the load. Weight of the operator, right? So back to my buddy there, we need to figure out how much he's attributing to that, right? What else? Okay, those are good. Those are the big ones, right? So truck weight, we account for the battery weight separately because we give the customer a range of acceptable battery weight values. So that might change. The operator weight, the length of the forks. So some of our trucks are single pallet length, they're 48 inches, and we go all the way up to 144-inch long forks that can fit 3 pallets. So based on how long the forks are, that locates your load wheels, which are in the forks, okay? And the distance of those load wheels from the caster wheel, because that's going to change what proportion of the load each wheel is taking. So we need to talk about the load on the forks, load distribution, how that's distributed. Now on our trucks, we say the load needs to be evenly distributed. But if you have 8,000 pounds up against the operator compartment, that's different than having 8,000 pounds hanging at the fork tips, right? That's a different loading condition. So we need to find the reaction at the drive wheel, the reaction at the 2 load wheels, the distance from the caster to the center of gravity of each of those things to find our moment arms, right? And what we're interested in finding out is the reaction force at the caster wheel. So how do you find a reaction force? What do you do? What do you draw? Oh, free body diagram, right? So we do a nice big free body diagram of the pallet truck in its loaded condition. So as you can tell by the grid line, we do this in Excel. So this is a CAD rendering of the truck. We account for the battery weight, the truck weight, the operator weight. Worst case scenario, we have a triple pallet length truck, so we've got 3 loads, and we have the reaction of the drive tire, because that's taking some weight. We have 2 load wheels in the fork, so that's taking some of the weight. And we're interested in RCST, which is the reaction of the caster. That's what we're interested in. In order to, so sum of moments in the X doesn't matter here, right? We're just worried about the Y direction, so we do sum of Y, we do sum of the moments. Here are all your different moment arms to all your different load centers, right? Now, again, if you were in POE or a physics class, you might do all this by hand because you know some of these numbers. You don't know what some of them are. But in industry, we can put it into Excel because Excel is nice with math and formulas like this, right? So it's a little hard to see these numbers, but we found that the worst case is our 8,000 pound capacity truck with triple pallet length. Our maximum battery weight is 1,500 pounds. We say the maximum operator weight is 500 pounds, so we say you can have an operator up to 500 pounds running this truck. And then 8,000 pounds evenly distributed across those 3 pallets would be 2,667-ish pounds per pallet. So it does all the math here for our reaction forces, and we find that the maximum force that this caster is going to see is 2,118 pounds with maximum battery, maximum operator, maximum truck load, maximum truck weight. Sound good? That's simple, right? So this is kind of the design we initially came up with. Does that look good? Anybody got any problems with that math? Did we miss anything? Doesn't look bad, right? Looks okay.
How many casters are taking the weight?
What's that?
How many casters are taking the weight?
It's just this one on the other side of the truck. So this does everybody agree that that's the number we need to design for? Plus our factor of safety? Nobody's jumping to say yes. What went wrong? We put a caster on our truck in the test lab and it failed after only 10 hours. What went wrong? What didn't we think about? I'm not going to say the gentleman's name. So the gentleman who spent about 6 months on this design is no longer with the company because he didn't do a very good job of following the design process. Through his design, he didn't hold any technical design reviews. He didn't have any other engineers look at the design. He went through all this and ordered parts, didn't have any reviews. And we didn't catch that there was one very obvious big thing that we didn't account for. So what was our free body diagram? The truck's sitting still, right? So what didn't we think about? So we didn't think about, so that was the static loading condition. We didn't think about the dynamic loading condition. So when you're driving your car around school, and you go over the speed bumps, you're adding extra force to your tires than when you're just sitting on the ground. This engineer did not have design reviews, and nobody saw the fact that he never accounted for the dynamic loading condition of going over a broken pallet board, going over a pothole in the factory floor, going over floor joints where there's an inconsistency in the floor, maybe hitting a ramp to go up a ramp. Those are extra dynamic forces that you only get when the truck is in motion. Didn't account for any of that. So after this gentleman left the company, he left the company on his own terms. It wasn't because of this, but this is a big deal because you can't have a customer order a truck and then 10 hours after they start using it, which is 2 shifts, have part of it break. That's not good, right? That doesn't make the customer too happy. So what we went through is we actually took some of those samples that we ordered that we knew were no good. We put them on a fixture that we welded 1/2-inch bars to, and we put strain gauges to see how much force those casters were actually seeing over bumps. It turns out we were seeing 21,000 pounds of force, which is 10 times that number. So our caster is seeing 10 times the force what it was designed for. That's why it failed after only 10 hours of use, right? Okay? So we worked with the caster supplier, we redesigned it. So here's our threaded rod that's used to adjust the height. We made that bigger in diameter. We made this blue housing, we made this wider at the top, and we put a bushing or a bearing in between the outer housing and the inner housing to transfer some of that force to the housing, as opposed to having that threaded rod take over. Because as you can see, we have a threaded rod fractured in almost an identical manner in all the samples we did. It failed the exact same way, so we knew where the failure was. It was very consistent. We had pictures of about 10 of them lined up at once, and they all looked exactly the same. And most of them fit together pretty well. If you tried to put them back together, the threaded rods, the failure mode was the same across all models.
Did it ever fail when it's not moving, or only when it's moving?
Only when it was moving. Never just sitting there did the caster break. So based on the analysis that was done, it was a good design for that loading condition. But for what the truck was actually going to be doing at the customer, wasn't a good design for that. So we went through and did this whole redesign. So that sample that I showed you pictures of, I think, was sample 4. So we did a bunch of samples on that drum test, about 7,500 bumps. After we did that, we said we need to survive 100,000 bumps. So we made some design changes, did a couple samples, almost 50,000, a lot better. Not what we wanted yet, not what we put in our application spec that we said it needs to survive this amount of testing. So we made some more design changes, tested a few samples, 128,000 bumps, 1,600% improvement over the original design. So that's good, right? Now we have a good design. Bad part is because we didn't follow the process the first time around, this delayed the project 6 months. We were supposed to launch in June, and we didn't launch until November. So the project was on track. We were actually going to launch early, and we went from a May, early June launch to a late November launch because of this problem. We had 5 engineers working full-time for 6 months to solve this problem because the first engineer didn't follow the process, right? So it's important to follow that process because things like this don't happen when you follow the process. We would have caught this. 15 engineers sitting in a room, someone would have asked the question, did you think about the dynamic loading scenario? But because that never happened, I was never caught, and this is the result. And this costs the company money because we have extra time, extra money being spent. We're buying parts that are no good. We had parts on order of this design already that were being made at the time when we found this out. So we're ordering parts that we're going to throw in the garbage. Now, the good news is we were able to use them for testing, so it wasn't a complete loss, but we ordered a bunch of parts that we knew were going to be no good because we already had them on order because we thought we were ready to launch. So that's money out of my pocket, right? It's not good. That doesn't make the customer happy. It doesn't make your employees happy, right? So process is important, and this is a great example. Questions on this? This is my favorite one because I'm very, very close to this one. I think we've got a few minutes. So these are just some words of advice, and then we can have a time for a couple questions. Yeah. Hopefully it's come across that I've been comfortable with the content I've presented. It feels like hopefully you get the sense that I know what I'm talking about a little bit when it comes to this stuff. Be comfortable presenting your content. You do presentations in PLTW for a reason, because you need to get used to doing that. When you go into a conference room with 15 other engineers, you need to present your ideas, you need to know your content, you need to know your audience, you need to know how they learn. You might have electrical engineers, you might have software engineers, you might have mechanical engineers, manufacturing, assembly engineers, quality engineers. They all learn differently, they learn in different ways, they have different things that matter to them most. You need to be able to connect to all those folks, and even non-technical people, like I said, sales and marketing, logistics. Logistics may not care so much about how much force the caster is taking. They want to know when you're going to be done designing it so they can order parts, right? So you need to know what's important to all those people. Clear and concise, making your reports quickly and effectively. That's always important. It's not always the easiest thing to do when you've got a lot of content to go through, right? But that's important. Being a good team player. So you're going to be working in a lot of those teams, different engineers, different people. It's important to work together with those folks and know their strengths and weaknesses. I have this as 2 different bullet points because I think they're 2 different things. When you're working on a project with mechanical, electrical, software, everybody's got a different area of expertise, right? They've all got something different to offer, and they've got different things that they're really, really good at, and different things where other people are a lot better than they are. An electrical engineer may not know so much about free body diagrams and mechanical loading. A mechanical engineer isn't going to know how a certain component needs to be wired up or why a certain software parameter is what it is. Okay, so everyone's got something different to offer. I'll jump back up to this one. So there's a lot of talk in industry about, is it better to know a little bit of everything, or is it better to know a lot about one thing? How can you become a valuable asset to your company or your project? It's a little bit of both, like most things, right? So if you would have asked me 5 years ago in engineering school, Danny, do you think you're ever going to be doing electrical work? No, I don't like electrical work. I didn't like circuits. I didn't like circuits lab. I don't like any of that stuff. I wanted to stay as far away from electrical as possible. But as a mentor, one of my co-ops said, 25 years ago, mechanical engineers just need to know how to design a desk, right? But for some reason now we put a camera in the drawer. So you need to know a little bit about electrical. You don't need to know everything. The electrical engineer, that's his job, or her job, right? But you need to have some idea of how that interacts with your mechanical system, and vice versa. Do it right the first time in quality and integrity. So that's why I like doing that caster example last. So if you notice here on my pinky finger, my right hand, I have a stainless steel ring. This is called the engineer's ring. When you graduate from engineering college, you have the opportunity to take the oath of what is called the Order of the Engineer. The Order of the Engineer started as an organization dedicated to driving for quality integrity, and engineering ethics. Back in the early 1900s, up in Quebec, there was a bridge being constructed, and the engineers cut corners on the design to meet their deadline. What happened during the final phases of construction, the bridge collapsed and killed over 100 people. Construction workers, engineers, field surveyors, and the original Order of the Engineers rings were built from iron from that bridge. So it goes on the little finger of your working hand, so that when you're writing as an engineer, it constantly drags across the work surface you're on as a constant reminder for engineering ethics, the safety of the public, right? Driving for quality results and engineering integrity. Very, very important. I highly recommend, if you do go to college for engineering, you'll have the opportunity to take the oath of the Order of the Engineer. I wear this every day, and except when I'm in the lab and don't want to get hooked on something. But we have several engineers who wear this ring all the time. So in that last example, is a good example of doing it right the first time, because for us it's a caster wheel, right? But if that's NASA or Orbital, or if it's Fisher-Price, it's not a big deal. Toy breaks, buy another one. If it's a rocket, right, or an airplane, or a bridge, it's a big deal, right? So that's very important. So that's all I have for you. I think we got a few minutes if there's any lingering questions. Hopefully you kind of sprinkled them in throughout, but if you have any general questions or questions that weren't covered, feel free.
Do you have like any patterns that you design that are like under Raymond, but like you design them?
So I don't have any. I've only been there about 3 years. A lot of my coworkers do. Raymond actually does do a rewards program for if you get a patent, you get some monetary reward. I don't know what it is, but they'll go. The CEO and the head of engineering will go to the patent approval process, and they do it up. We actually have on one of our walls, engineering is a big graphic of a lot of different engineering patents that we have that are significant. So I don't have any personally, but Raymond has a ton of them. A lot of my coworkers have them, so that is something that we do. Other question? Yep.
What's your proudest achievement?
My proudest achievement in general, or Raymond? In general. Oh. Well, in general, actually, my proudest achievement actually isn't engineering related at all. My other hobby is bowling. I've been a bowler for 25 years, and back in January I bowled my first 300 game. So I wear my 300 game. My grandfather, who's still with us on my dad's side, has been a bowler for 60 years. My grandmother, who passed away my senior year of high school, was a bowler. She taught me how to bowl, and I always said, one day I wanted to bowl at least one 300, so I got it back in January. So that's probably my proudest achievement in general. In terms of engineering, the stuff I've done at Raymond is real cool, but I really always look back to my first co-op experience at Fisher-Price at the Batmobile and the Dinosaur, where I could actually just go to Target and buy it off the shelf and say, yeah, I did that. Because I could take it apart, I could play with that toy. It sounds really silly, right? But I've got like 4 or 5 of them sitting at my desk drawer at home. Say like, yeah, I did that. And they'll remember that 5 years ago when I came in, I was given a presentation on that and had, a Creo video on how that all works. So, it's always fun to see something, right? When I go to Home Depot with my parents, they have Raymond trucks. If you go to the Home Depot down past Dorney Park on Lehigh Street, they have Raymond trucks there. So next time you go to a Home Depot, they'll probably have Raymond trucks sitting around there. EDD? Oh, so we did a 3D laser scan where we took a part, we actually 3D printed a part, and we had a laser and a camera, scanned it, and it gave us a CAD file. And it gave us a map of the part, and we were able to put that map and do a CAD file on it. So that was more of a reverse engineering problem. You have something, Jay Leno does a lot of laser scanning for his car and motorcycle collection for old parts that he can't buy anymore because they don't make them anymore. He'll take the old part and he'll 3D scan it, and then he'll have someone make a new one so he can restore his cars. That's just a common application for that. It worked pretty well. we had a lot of problems with the electrical part because we had 2 guys with mechanical engineering interests, and electrical is a big part of that.
Okay, I wanted to get in because you guys out at 18 or 17? What time's the bell ring? 17. Okay, and so 17 the bell rings, right? Okay, so I'm just gonna first of all, I want to thank Mr. Miller again, and quickly, I just want to point out a couple things real quick here before the bell rings. First of all, you can see why I was very grateful that he was able to rearrange his schedule and stay an extra day. How many are in either IED, SIM, aerospace, or EDD? Not IED, forget IED. EDD, all the upper levels. Who's in the upper level right now? Not, okay. Tell me, all this stuff you presented, these examples, didn't it hit home on so many things you learned in these other classes? IED and POE, a lot of this is going to make sense. I want to thank Mr. Miller for giving me examples because I got his PowerPoint. And when we get into some of these things in these upcoming units for my POE students, and I know the IED students, again, we're going to use some of those examples as real-world examples to support the curriculum. So thanks once again.
Thank you so much, guys.